Hello friends, in the series of learning computer organization and design, today we will discuss about asynchronous data transfer in input-output organization. So this is the entire agenda of the session. We have already covered peripheral devices and input-output interfaces. Today our focus is entirely on how the data transfer will take place in asynchronous manner within the machine. Then in the later part, we will discuss all these upcoming topics. So let's start understanding about asynchronous data transfer. So before beginning, the very first topic that came into picture is about understanding what exactly is data transfer, right? So simply it means that whenever we are having two separate units wherein one unit is the source and the second unit is nothing but the destination, or you can also say it like one is the sender or another is the receiver. We can take it in any way. Now my point is that how this source which wants to send the data is responsible for sending the data to the destination, and how the destination is replying back, and you could say that how the destination or the receiver is there to send back the data to this source, right? So this is what exactly we are going to learn here in this data transfer technique. So on a broader level, we are having two categories of this. Data can be transferred in two ways. One is the synchronous data transfer. So what happens in case of synchronous data transfer? As the name simplifies, there is a sync required. Okay, so what happens is there is a common clock pulse required between the sender as well as the receiver, or I should say that both the parties, being it sender and receiver, remain need to remain active. Only then the data can transfer can take place. Means there should be a sync. They should know the resource is sending the data, and destination should know the data is coming, and I have to be active and I have to respond back accordingly, right? So as we are learning about input output organization, so let's understand this entire concept of source and destination in that way. So what we are doing is, in case of synchronous data transfer, the interface, we know that the two parties, two different units, being it CPU or being it IO devices, are communicating together or with each other using the interface, right? So what happens is that the interface is sharing the same clock pulse between the IO device and CPU. And what is happening then? It means that whenever the common clock pulse is there, right? So we simply depict that this kind of data transfer is nothing but the synchronous kind of data transfer. But there is a point. The point is that these two units, being CPU and being IO, these are independent of each other. Means the CPU never knows when or at which point of time input output device will send the data. Similarly, the CPU is all we cannot determine the time when the CPU is available for taking the data from input output. Means both are the independent unit. They don't depend upon each other. So having a common clock pulse between the two, it will be very hard for us to get that. So that is why within the data transfer technique, we are always following the approach of the asynchronous data transfer. Okay, so this is the one point to understand, that data can be transferred in input output devices and the processor, right? How? Through the asynchronous manner. Now let's understand about in deep about this asynchronous data transfer. So the idea is that both the CPU and interface, or being IO devices, anything, these are independent unit, right? Because interface is basically attached to the IO, input output devices, or the peripherals. So the point is that each of these two units, being it CPU or IO or interface, these are having their own clock signals. So what happens in that way? It's okay. In asynchronous data transfer, that thing can happen. So asynchronous data transfer between two independent units requires that control signal be transmitted between the communicated unit. So what we are doing is, in this case, we will always, whenever the sender is ready, okay, it will send the data to the destination or the receiver, or when receiver will be active, receiver will read the data. But according to this, it will also send back the acknowledgement that yes, I have received your data. Otherwise, how could the sender will know that it has taken the data? So that is why in asynchronous data transfer, we have to work upon the facility of having a control signal. So what are those two control signals? So those two control signals are the strobe as well as the handshake. Okay. So now we are going to describe in detail about these two control signals which are available in this input output data transfer. So by strobe, which simply means that it is a kind of control signal which indicate the time at which the data was transmitted. Okay. And the another method, which is handshaking, it will simply provide me the acknowledgement signal. Like usually it is an agreement between the two different units that the sender has sent the data, okay, the receiver has also received the data. Always in case of handshaking, there is an acknowledgement signal been there which has been sent by the destination, that it has taken the data which has been sent by the sender. So let's start understanding about these two control signals in more detail. So here is the first signal, strobe. For your information, I would like to let you know here how we are going to learn these two control signals. So the control signals in asynchronous data transfer we have learned. One is the strobe and another one is the handshake. Now strobe can be initiated from the source end as well as from the destination end. We will learn the both ways, how the strobe initiated from the source side will work and how initiated from the destination side will work. Similarly is the handshaking. Handshaking can also be from the source initiated as well as from the destination initiated. Now, one thing that you should need to know here is that this source or this destination can be anything. Like sometimes the CPU can be the source, maybe for the other time the IO device can be the source. Okay, similarly here, sometimes IO device can be the destination and another time CPU can be the destination. Same is true for this strobe signal also, right? So that's why instead of writing here the processor or the peripheral devices being source or destination, we have simply taken the term or used the term as a source unit and destination unit. So what will happen when the strobe control signal is initiated by the source unit? So first of all, the data will be sent through the data bus. Every time whenever the source want to send the data, that will always be sent through the data bus. So first of all, data bus will send the data to the destination, and then only the stop control signal will be sent to the destination after some few delays, which will depict that the data has been sent by the sender. Okay, or it will also depict the time when it has sent the data. So that is why in the timing control pulse, it has been written here that the data is first of all get active. The clock is becoming one here, right? The valid data will be provided here. And then only secondly, after a little delay only, the second timing signal, which is representing the strobe signal was sent, which is simply depicting that the source has sent the data to the destination. So this is how the source initiated strobe signal will work. Now, if we have to learn about how the destination initiated strobe signal works, so first of all, the destination unit, if it is ready to transfer the data, it will send the data, send a control signal to the source unit that I am now ready to send the data, to receive the data. Destination will receive it. Then only after receiving this strobe, the source will send its data on the data bus, and then data will be validated and will received by the destination. So this is how this strobe signal initiated from the destination and will work. So let's understand the timing signal here. So as I said, as it is destination initiated, it means that signal should has to be initiated first. So that's why you can see here the strobe signal is initiated before, okay, and only then the source was ready to send the data over the bus. So that's why there is a little delay here. So while designing the diagram or the control signal, you have to keep your eye on these things, okay. Let's start understanding about the handshaking part now. Handshaking, as I said, handshaking can further be of two types: source initiated and destination initiated. And in case of handshaking, one important rule is there: the data accepted signal should always be sent, right? So, what if the handshaking signal is source initiated? Source is saying now I am ready to send the data. How this entire thing will function? So this is the sequence of events. I will explain from here only. It will make the things more easier. First of all, as it is the source initiated, the source will start the communication. What it will do, it will place the data on the data bus, and as soon as it places the data on the data bus, it will enable this signal. That data validate signal is been there. Data valid signal will only get generated once the data is placed on the data bus. Okay, so then it will enable the data valid signal. So this is the first point when done. Now this data which is available on the data bus is being sent to the destination. As soon as the destination will receive the data, it will accept this data which is placed on the bus, and it will enable its another signal which is the data accepted signal, this signal. Now it is coming from the destination end. As soon as the source will receive this data accepted signal, it will get to know that okay, the entire data has which it wanted to send to the destination has been received by the destination. So what it will do, it will now disable its data valid signal and invalidate the data on the bus. Means now it will say that now I am not sending any data. It will invalidate the data. And then third, what it will happen, as soon as the data from the source is not being received by the destination end, it will also disable its data accepted signal, and it will again start the new thing. Like it will again generate a new signal if it is from the destination end, that we are going to learn in the next slide. It will enable the ready to accept data signal and again being received by this source unit. So this is how entirely this source initiated handshaking will work. So again, I would like to depict from here also. First, the data is being placed in the data bus, and as soon as the data is being placed, the data validate signal will be activated, and then the destination will say that the data has been accepted, and then accordingly it will invalidate the data, and the data valid signal will be invalidated, and the data bus will stop sending the data over the bus. In the same way, the destination initiated handshaking will also work. Here, the first point is that ready for data signal is to be initiated by the destination. Only then the data will be placed in the data bus and the data valid signal will be sent. So here, this is how the communication will take place. First of all, the destination signal will send a signal to the source that it is enabling the ready for data kind of signal, ready to accept the data. Once the source has received it, this particular signal, acknowledgement you could say, right? So what it will do, it will place its data on the bus and it will enable the data valid. After that, after the destination has accepted the data, now it will disable the ready for the data signal because the required data has been received. And similarly, data valid will be disabled and it will also invalidate the data which is available on the bus. So accordingly, if now the source is ready to send the data, it will again start from its initial state and will send the signal to the destination that now I am ready to send the data, and will place the data, and this is how entirely the communication will start. So if we look at the timing diagram here, first the ready for data signal has started, right? And then only data was, then the data will be placed on the data bus. And after that, the third time, what will happen? The data valid signal will get activated. So this is how entirely the destination initiated handshaking will work. In certain cases, it might be the case that the timeout will be arising. Like destination is saying, I am ready to accept the data, but source is not responding back. So there would be a time. If in that particular given time, if the source is not receiving or the source is not responding back to the destination, then we will say it is a timeout being generated. Okay, so this is how entirely the asynchronous data transfer can take place through the strobe as well as through the handshaking. So let's understand more about how the data is actually being transferred through the asynchronous serial manner. So usually what happens is that the data is taken in a serial form, means bit by bit data is transferred, right? So what happens now if it is a synchronous transfer? Like we know that the transfer of the data can happen in two ways, in synchronous and in asynchronous manner, right? So if it is synchronous, then it is the necessity that both the units are available and are sharing the common clock pulse, and which are transmitted continuously. That is the another aspect, at a rate dedicated by the clock pulse. We need to continuously transfer the bits, because both the source as well as destination should remain available and should be having a common clock pulse. But this is not an ideal case in case of the input output devices. So that is why we concentrated more on the asynchronous kind of data transfer. So let's understand about what happens in asynchronous transfer. So binary information is sent only when it is available. Definitely, as I said earlier also, we never know when the source is available and destination is available. Because in case of asynchronous, source is having its own clock pulse and destination is having its own clock pulse. So when the clock is active for source, it means it is available. When the clock is active for destination, it means destination is available. So point is that the information can only be transferred when any of the entity is available. Otherwise, this line will remain idle. Okay. So how to determine that that information is to be sent, and how to determine that now it is the idle period? For that, we have a rule being generated here. We are using these special bits which are inserted at the both ends of the character. So I will let you know about this. The character consists of three parts. Character is like, this is the character, let's suppose. This is these characters means in the data which we want to transfer. Okay. So always above this character bits, we will be having a start bit, which will always be zero. Like this is the low, this clock pulse is low, so it will always depict that it is the start bit of the character. And in between that will be the data or the character bits. And after this data, there will be a stop bit, that now I have stopped sending the data. Always it will be the one. See, it is always the one. When you will get more than two ones and threes or fours, right? So this is how you are getting the data. One, one, one. You are getting a number of times. It means now it is the idle state coming, and the sending of the character bits has been stopped. So this is how entirely this asynchronous data transfer will be sent. We always are injecting some special bits or special characters here. So the initiation of the character bits will start from a start bit always. It is always 0. And the end bits and the stop bits are always the 1. So there are some rules which we need to focus upon in order to send the data through the asynchronous transfer. The first rule is, when the character is not being sent, the line will always be on the one state. Means the stop bits will be there. Okay. So initiation of the character transmission is detected from the start bit, which is always 0. So I already taught you there is always the start bit which is 0. So after continuous 1, once it is a 0 coming, it means this is the start bit, and then the character will come, and then after the character bits are over, then what will happen, it will again continue to the having the one state, right? So the character bits always follow the start bits. So as I already told you, after the last bit of the character is transmitted, let's suppose this is the last bit, stop bit is detected when line returns to one state for at least one bit time. So whenever it is coming one time, one, it means the stop bits have arrived. So this is how we will be able to understand that the characters are available or the idle line is there. And this is how the entire asynchronous data transfer will happen. So with this, there is a terminology or a technical term that arises, that is the baud rate. Baud rate is determining in 1 second how much of the data, how much data we are going to transfer. Okay, so once we will know this baud rate, it will be very easy for us to determine this. Like if I am saying I am able to send 10 characters in 1 second in 11-bit format. So 10 characters are there. Each character is of consisting of how many bits? 11 bits. So definitely in 1 second, how many bits are transferred? So 11 into 10 means 110 bits are transferred in 1 second. So this is how you need to determine the baud rate. It simply depicts that in 1 bits, how much data in the form of bits are being transferred. And now this is the last part of this entire session, which is universal asynchronous receiver transmitter. It is also known as UART. Okay, just the name, universal asynchronous receiver and transmitter. So what happens? This basically, this diagram is depicting a typical asynchronous communication interface. Okay, we have already learned about the interfaces in the previous session. So what the interface will have? A transmitter resistor, a receiver resistor. These resistors are nothing but the data resistor. Okay, which has the ability to take the data and to take out the data. And then we are having a control resistor and a status resistor. But now this universal asynchronous receiver transmitter will work upon the clock signals. When the receiver is there to send the data, when the transmitter or destination is there to send the data accordingly. So first of all, let's understand about these role play of these all resistors. Only then we can understand the functionality. So the idea is, the very first one is that this transmitter resistor, it will accept the data in the form of bytes from the CPU. See, this direction is from here, from the CPU. Any output being generated by the CPU will be taken into this transmitter resistor, and then serially, this is a shift resistor, means bit by bit, the data will be transferred in this shift resistor, and then only it will be transferred back to the peripheral devices or to the IOs. So this is how the transmitter resistor will work. Similarly is this receiver resistor. This receiver resistor, which is available here, how it is taking the data. See, data is received from the IO devices bit by bit because it is an asynchronous serial transmission. Okay, in the shift resistor, through this shift resistor only it will be taken into this receiver resistor, and whenever the receiver resistor will get activated, okay, through this timing and control signal and all, it will be available, applicable to send its data through this bus buffer to the CPU. This is how it will work. Then there is a third one, which is the status resistor, this one. So whatever is the status, like in the status, we will be having the flag bits, whether the data, the input output device is available or not available, or if there is some sort of error been there, all these things will be present here in this status resistor. Error in form of communication. Okay. Then there is a control resistor been there. Control resistor will help me in understanding at which rate the data is being transferred, okay, and how many bits are to be transferred, and what are the how many number of stop bits are there. So all these things will be dedicated within this control resistor. Only then the communication will start. So we have already learned similar kind of diagram in the previous session also. So chip select is there, which will, if this is enabled, only then the communication will take place, otherwise it will not happen. Okay. So here what we are having a resistor select. So resistor select is one only. So if the value of resistor is select is 0, so it can perform both read and write. So it will be able to receive the data from the input out peripheral and to transfer back the data from the CPU to the input output peripheral. Okay. But if the resistor select value is 1, then what will happen? So again, it will be able to read the data from the status register about like what is the status and is there any error bin there, what is the flag value, all such things. It can easily read the status of any of the register which is applicable to this peripheral devices. Similarly, it will also depict the data, or it will update the data into the control register also, like how the data will be transferred, what will be the rate at which it will be transferred, right? All these information will be provided here. So this is how entirely this universal asynchronous receiver and transmitter will work. Depending upon the register select values, any one or two value will get activate and accordingly it will respond. So with this, we have learned about the asynchronous data transfer in detail. Thank you so much for joining the session.